The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, it's showing that I am unmuted and showing my screen. So this is one of the first few times I've done a webinar. My name's Eric with Bobcat Tech Support. I also do the demonstrations of the software program normally, and started doing the webinars these past few weeks now. So if anyone would be able to let me know in the chat that you're able to hear me or not able to hear me, I'd appreciate it, so that I don't I know one time a couple weeks ago I started first 5-10 minutes, I didn't realize nobody could hear me. So yeah, let me try to open up the chat here for any questions. Can hear, awesome. All right, cool. And hoping you guys are able to see my screen as well. Got BobCAD version 34 open, showing a cylindrical piece of stock here, and mainly what we're going to be going over today, 4 and 5 axis milling, and it's going to be going over the 5 axis standard milling here. Mostly what we're going to be looking at is the 4 and 5 axis indexing, the multi-axis drilling for indexing to make things easier that way, and also 4 and 5 axis deburring. You can see the different part files I've got open up here in BobCAD for right now. Yep. So a couple of you guys said you are able to hear me, so that's awesome. Just trying to make sure if anyone can answer me that you're able to see the screen here, so that we can get started here in the next few minutes. See if there's any other attendees that are going to be joining. So I've been with BobCAD for about 5 years now, and mainly doing the demonstrations of the software program. I think for the past 3 years now, I've been doing demos for any customers or any prospects that want to take a look at new modules or take a look at the software program as a whole, the different features, new features in BobCAD version 34, or in our plugins for SolidWorks or Rhino now. So it might be going a certain direction here. How can I see the chat? Yeah, I'm not sure, Alethea, how you can see the chat. There should be a window there to, I mean, you did enter your own question. I don't know if there's any answering that I can do in here. Again, just kind of getting started learning this type of webinar type of feature here. Let me, or go to meeting. Does 5-axis support HSM or HEM toolpaths? Yes, Eric, it does. So 5-axis indexing supports high-speed machining. You can do your we're actually going to be going through 2-axis pocketing. We can take a look at the high-speed machining options, and also 3-axis high-speed machining features in here as well. Yes, Alethea, I can see any questions that you've got. And Yeah, I see Bill's in here too. Good to see you, Bill. Yeah, so any other questions, please let me know in the chats or in the questions box there. I may not be able to get to them until after the webinar here, but I will answer any questions that you guys have. Once I get started, I'm probably gonna start kind of getting on a roll here. Yep, so Althea, yeah, I'm able to see your questions, and I'll be presenting here today. My name's Eric, for anybody else that is just getting here in the webinar. My name's Eric with BobCAD Tech Support. I also am they call the demo tech. I do the demonstrations of the software program for anyone interested in new modules. So again, it's going to be probably presented, this webinar here presented more as like a demo. That's just kind of what I'm used to, but I'll answer any other technical questions that you guys have at the end here. But I'm going to try to get as in-depth as possible with the 4 and 5 axis indexing today for 5-axis standard, and the 4 and 5 axis deburring for the 5-axis standard toolpaths. And before we get started, again, there may be some attendees rolling in here in the next couple minutes. Before we get started, the 4 and 5 axis indexing is in the 5-axis standard. The 4 and 5 axis deburring is in the mill 5-axis standard. However, you do need to have the milling 3-axis premium included in the package that you have. And the 3-axis premium includes these 3-axis surface-based toolpaths. The morph between two curves is a very popular one that I frequently use. Morph between two surfaces. It's morphing the toolpath from one surface or one surface edge to the last one that you select, giving you equally distanced cuts here. With the morph between two surfaces, you're going into a channel and selecting the side surfaces so that there's no gouging there. Flow line, the morph between two curves and flow line, they support undercutting, so you can use a lollipop tool for this here. So yeah, these different surface-based toolpaths. The deburring is in the 3-axis premium. The turn milling is in the 4-axis premium. This is an advanced roughing operation around a rotary axis. And then the 5-axis Pro would be, 5-axis standard wireframe, multi-axis machining, deburring, and the surface-based toolpaths are in 5-axis as well. And then now we have added the 5-axis premium. 5-axis Pro is swarf machining, and then 5-axis premium toolpaths that we've added now are multi-blade for impellers, port machining, and we did add deburring for the 4-axis premium now as well. So these three are newer milling operations here. Let me know in the chats if you guys are interested in looking at those anytime in the near future, or if you want to contact us to do a demo on that. We're always available to do that as well. All right, so it's about 10 after, so I will start the webinar here. Again, we're going to be going over the 4 and 5 axis indexing and the 4 and 5 axis deburring milling operations. The deburring is a newer option that we have now. It's in the 5-axis standard. However, you do have to have the 3-axis premium toolpaths included in your package for that to be unlocked. So we'll take a look at indexing first. In 4-axis, we can see this cylindrical stock that I've started with, and we're going to be indexing around the different surfaces that we have here created for this part file, and facing off, I believe, all 5 of the surfaces here. So facing off all 5 of these planes. And then after this one, we're going to be doing a 3-axis roughing and finish here, a pocket, just a facing operation here, and then a drilling operation here. So to start with, just as we would in any other milling operation, we go to CAM, start a new job, select milling, and our machine type. And I'd be selecting our BobCAD 4-axis milling machine or any other 4-axis milling machine that you have to be able to see that in simulation and have everything posted correctly with that post processor linked to that machine. So next we've got our workpiece. We're selecting our part file here. And then we're defining our stock that we're starting with, our initial stock, in our stock definition page. So whether it's rectangular, cylindrical, I'll calculate the stock. This is extruding in the z-axis. Our rotary axis is in the x-axis, so the cylindrical shape will be extruded in the x-axis here. Kind of goes to a default position, so I just have to click the calculate stock button again for it to create the cylindrical stock around the part. And a newer option that we have in here also for cylindrical stock, we have bounding box and bounding cylinder. You can see it just kind of interpolates, I guess you could say, interpolates or creates a cylinder around the part file as the smallest amount, I guess you could say. But we have this bounding cylinder, so the bounding box kind of stops at the, I would say at the average diameter of the part file. The bounding cylinder, once I hit calculate stock, it'll create the stock around all of the areas of the part file that we have. So even going above this boss, it will create the cylindrical stock above that, a large enough diameter to encapsulate all of the part file. And then also at the height, it creates the specific height that we have of the part file. I can add to it here in these parameters. I can add an offset in it in any direction as well. We can extrude out from a sketch, from wireframe to create the stock. We can select an existing solid model or STL model, so that if we had a casting or anything else, any type of stock that we have left over from previous operations, we can tell the software exactly how much material is remaining to before our milling operations are being programmed here. We can also revolve the stock from the profile of the stock as well. So we've got our cylindrical stock here, and then we've got our machine set up. It'll be in the x-axis through the center line of the stock here. And we'll click OK. We'll go to my existing milling job that I have. So to create a new index onto a specific surface, we right-click on the machine setup, we go to additional functions, and we go to add index. We can pick a surface, and that will be the new Z direction, that the tool will be normal to this surface coming down in the negative Z direction from here. We could also pick from an existing UCS, from an existing user coordinate system. So if I can minimize this, that works. So if I go here to our UCS page, it looks like I have one already for this side here. I can create a UCS, select that surface as a user coordinate system. So if I wanted to draw the holes like we did in this part file, we can do that here, and then use the UCS as our Z direction, as our index. We could also select our index from another existing UCS, from the top UCS, from the front UCS, from the side. And we can also reverse the direction. So right now the Z-axis is pointed inside of the part. If I reverse it, that'll be the new Z positive direction if I selected that. So I'll go back to the pick a surface option and then highlight the or select this surface. So that's the new index, the new Z-axis location, so that the rotary axis will rotate and lock to that new location there. We'll always want this checkbox used using machine setting for posting, so it'll post the A or B axis rotation so that we have that correct index on our machine there. Then from here, we have our index. We right click on it just as we would create a new milling operation in the machine setup. We would right click on the index system that we're using and go into the different milling operations that we have here. So then we've got what we're doing with this one is mill 2 axis, and just as we would go through the workflow of creating a milling operation under a machine setup, it would be the same workflow as creating that operation under the index, selecting our geometry, either selecting the surface here, or we can select the edges of the surface here. I can select each one individually. One technique that we use quite frequently to help save us time, if the geometry is a little more complicated than this rectangle, I can right click on a surface edge, and we've got two options here to chain select surface edges. So constant Z would be selecting all of the surface edges in the same Z direction of our index here. And loop selection, you can see that it highlights the rectangle. It also highlights this pentagon shape here around the part. So if I select one of these edges, it'll select the rectangular chain selection of the edges here. If I select one of these edges, it'll chain select all of these edges around the five-sided pentagon shape here. Now, of course, that's not on the same plane as our Z location, so it gives us some weird geometry or weird toolpath highlighting there. So we'll delete that, go into loop selection just so I can select the rectangle around it with that loop selection option, just as I did with the constant Z. We can pick the bottom of our total depth here. And from there, click OK. Our next page, setting the picking top, so the very top location where we're starting this operation, and the total depth here. So 625 above this Z0 location of the surface, and we're going down 625. Next page, our different operations for 2-axis milling, just as they are in the standard 2-axis milling here. We're just doing a facing operation. Tabs, we have options for profile cutting and leaving tabs in the profile. Work offset number, setting number 1 as G54, 2 as G55, 56, and so on. Multi-axis post, that's set up by default for you with your post processor, so there's really nothing you need to change in here. And then setting up your tool, your feeds and speeds. Just as with all milling operations, you can go into the tool library, find all of your tools here, add or delete tools, modify tools, set up your feeds and speeds for each tool accordingly. or you can use system feeds and speeds, which would calculate everything based off of the material you're using for your stock here. We have feeds and speeds for each material type set up automatically there. We'll go back into the feature for my facing operation here. What's really nice in version 34 from version 33 is you can double click on the feature. It goes right to the starting page of your feature going all the way down. Double click on the facing operation. It goes to your tool page because it's got the tool and goes right to that operation that you're doing there. That way, instead of having to right click, sometimes your drop down after your right clicking is down here. Sometimes when you right click, it's up here. So sometimes it's hard to find the edit option. You can just double click on stuff now. Pretty useful. We'll set up our tool. Set up our different cut patterns. Now, Eric, this is where you're asking about high-speed machining. We have one adaptive toolpath for facing here. So a spiral facing operation, or we can zig or zigzag back and forth. This would give us linking for each step over for zig or zigzag. The adaptive is constant tool engagement in this operation. And I'll compute that to see what it looks like. It'll be multiple passes or multiple levels going down. We'll take a look at that. You can leave a bottom allowance if you want to set up another facing operation for a finish pass there. You can leave a certain allowance for that last facing operation to clean up. We can do one single step down or multiple steps down, set a depth of cut for each pass, change that to 1/8 of an inch, so it'll be number of cuts will be 4. You can do even depths of 1/8 of an inch or defined depths. Change the depth of cut and it will get down to whatever the last pass is and clean off that last amount if you want to do different depths than the same even depths all the way down. And then our minimize retracts option, instead of, so you can see here, every pass it'll go up to the clearance plane, go across, plunge back down to the next level, go around, retract up, go across, go back down. We can minimize those retracts. So when it goes down, actually I think it goes down here. So it goes down, goes around, and then rapids down and then across. We can link, instead of a feed move, we can link with a rapid move. So it goes down, across, retracts down, retracts across, and then does the machining. Rapid down, rapid across, machining, and once it's done, retract back up. Then our next page, what type of lead in we're doing, vertical or parallel off of the stock, working our way in. Set the length there, set our lead out as well. Linking across each step over, if there's going to be any linking. With the adaptive, there won't be any linking when we're machining here. And then our advanced feed rate page, a newer option in here, where if we are not able to set a rapid rate in the G code, we can convert rapid moves to feed moves. We can set a rapid rate here within the G code, essentially, or another option as well in the advanced feed rates, we can set a feed rate for our lead in and our lead out specifically. So if we want to slowly work our way in or kind of go fast and then gradually slow down, different options like that. So we'll hit compute. We'll see the toolpath is a little different there. There's the adaptive toolpath instead of the zigzag that we had. We'll backplot that to see how it looks. Kind of step through, works its way from the outside of the stock, works its way in. And kind of does this spiral option, goes up and links to the next location there. And then from there, we'll index to the next surface around the part. We are doing Okay, so no facing operation to start with. We're just doing an advanced rough in this one. And Eric, that you asked about the high-speed machining. I believe this is high-speed machining. If not, we'll change it to it to take a look at that as well. Set our rapid plane, feed plane, top of feature where we're starting at this operation. We've got our advanced rough. You can do any of the other 3-axis milling operations in this index system that we're doing here. We've got our standard 3-axis standard tool paths, which is our Z-level rough, Z-level finish, planar, spiral, radial, and plunge rough. And then we have our 3-axis pro tool paths that we can do in the index system here. So from the Z-level rough, we have the advanced rough. Z-level finish, we have advanced Z-level finish. Planar, we have advanced planar. These options give us more optimized options in here. You can see from the planar, it has a standard step over. The advanced planar gives us a variable step over when we get into tight corners. Will give us a smaller step over rate in the corners to clear out as much material as possible there. And then it doesn't need to do that small of a step over on the top of the dome here. So we get a larger step over here and then smaller step over when necessary. And then with the Z-level rough, Z-level finish, advanced rough, advanced finish, advanced planar, they all have the rest machining option as well. So if you had a previous milling operation before that, you can set a previous tool and set the software will start where we left off from the previous operation, and you can see an example of that in the advanced rough here. Then flatlands, equidistant, pencil, project curves, and we also have steep shallow now. Steep shallow is basically, we look at it, it's a Z-level finish and a planar. So Z-level finish on the side walls, and then when it gets into the horizontal areas here, it'll do a planar operation, or a Z-level finish along the side walls and an equidistant along the horizontal areas there. So that's a newer operation that we've got here in the 3-axis Pro toolpaths. Setting up our work offset number, multi-axis post page, and then our tool that we're using. Here's our high-speed machining options for 3-axis roughing on the index. You can start with the parallel, so zig or zigzag in between inside of a pocket here. Offset in from the outside, in towards the center, or start from the center and offset our way outward for each step over there. And then here's our high-speed machining options with morph spiral and adaptive roughing. The tool will start at the center location, continually spiral its way out, keeping constant tool engagement the whole time. This is our zigzag method, so when it gets to the edges here, it's just going to go back and forth across it, across here, link back, across in the corners, and then the other 2 corners there. Or zig, where if you're just doing one directional cutting, it's going to spiral around. Once it gets to the edges here, it'll have this link in yellow and then going across, link back. And that's a rapid move, also considered tricoidal milling. And it will, you do have a setting to keep the tool down as close to the stock as possible, so it's not giving you those retract moves again here in 3-axis milling. So here we'll set our depth of cut and step over amount for each pass, and allowance, so we're leaving a certain amount of material for a finished pass to clean up. We're leaving this at 0 since we're just doing this roughing to take a look at today. Some other options in the 3-axis Pro here. You've got the top of job and bottom of job. So if there was a certain area that was already finished before this operation, you can tell the software where to start and where to end this operation. If this fillet here at the bottom was already cut to size, we can end it here, so there's not going to be any air cutting below that level as well with the bottom of job. Or we can just go to automatic, where it's just going to remove all of the stock that we have set up under the stock definition. Then our entry moves, if we're going to plunge down into the center here, plunge into the stock and mill away everything, we have some ramping options, a linear ramp or spiral, so a circular interpolation down into the stock. Or if we want to start from the outside of the stock and work our way in, we just uncheck this box for center cutting tool. And the tool path will start from the outside of the stock and give us this side roughing routine. If there is an opening from the stock there for us to start with, it helps with the life of the tool, so that the tool is not plunging down, is always using the side of the tool for machining. Then our next page, here's our rest roughing again that I was explaining. Here's our example. So again, if we had a previous milling operation, we can tell the software the previous tool diameter and the previous corner radius that we used. The software will calculate any areas the previous tool could not fit into and calculate just that tool path for us. So essentially, it's going to start right where we left off from the previous operation and avoid any air cutting from the previous operation we did. Then our next page, different linking for each step over. Again, we can do a full retract for each step over here, a direct link across, or an S-link, so it'll move in an S shape, just kind of start right before where we left off, clean up any areas that way as well. You have that option. Then our gouge check page, we can make sure the tool and the tool holder doesn't gouge into the stock anywhere. We also have a fixture option now. So if we are using a vise or using any clamps or anything, we can add that into the part file here as an assembly. Select that as our fixture here to make sure the tool avoids any areas of that geometry as well. Then our last page is our advanced feed rates. We've got our convert rapid moves to feed moves. We have a linking feed rate option in this page, so when we're linking between groups of geometry, we can set a feed rate for that to speed up that process. We also have an adaptive feed rate, which is volume-based, and also a radial chip thinning option. These options, you can set a minimum and a maximum feed rate. And for example, when the tool is getting into larger material at a time, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. So those are the biggest takeaways from the 3-axis Pro versus the standard. Is you have the high-speed machining options in the Pro, the rest machining option, and the adaptive feed rates for a constant chip load as well. And we'll compute this so that we can see the adaptive roughing here. Instead of, I think I had the offset option. So this looks like it's not going all the way down. See, okay, so we have a boundary. I might want to offset the boundary or deselect it altogether. Yeah, let's remove it for now and see if it gets down a little bit further, or if there's some other setting that I may have overlooked in the feature that may be restricting the toolpath here. But already you can see the high-speed machining, the tricoidal movements here with the adaptive roughing versus the offset. Yep, that went way too far down for the stock, so let's reselect the boundary. Again, I'll do the constant Z around. go back to the original toolpath and see why it's not getting down to this level that it's showing here. Probably just have to offset the boundary a little bit so that the tool can be inside of it. Cutting tool. I think that's what it is. I also have the machine flatlands option turned on. So what this will do is if my depth of cut goes 100 thousandths every time, and the depth is, for example, 410 thousandths, the depth of cut will only go down to 400 thousandths and leave 10 thou remaining. So the machine flatlands option would just give us an extra depth of cut there at the machining of the floors of the stock there. So with the boundary, I think that's what I'm going to have to do is offset that. So I'll just go to the layers. Let's see. Let's see if there's an option for that here. No. Yes, I'm just gonna go to offset under create 2D. Hold shift and click on one of these lines. So I'm chain selecting all of this and making the distance, I'll just say 375 to start with. And it's going in the right direction instead of the left, which would be going inside. And I'll make the corner sharp. I'll remove the boundary and reselect it as this now. See what kind of toolpath that gives us. So we're at this level right now. We should be going a little bit further down. We're going a little bit past the flatlands here into the areas of the stock here. I don't want that, so I'm going to change the boundary, change that offset to half of what I just did. So I want to offset for the radius of the tool, not for the diameter of it. Remove and reselect the geometry. Got a lot of geometry kind of intersecting there now. Well, not intersecting, but the toolpath is intersecting the geometry. Kind of hard to see. The toolpath is better. It's getting further down. I think what it may be doing is from the entry options, and I think a big thing is just the tool's not able to fit in here very much, and it's not able to fit probably based on the boundary here that I've got. So let's make the tool to 1/4 inch instead of 3/8. And then if not, I'll just we can go into a depth here, so not to waste any time. Just kind of plunge in, or we could do a circular interpolation in. So you guys have any questions in the meantime? Nothing so far, I think. Cool. All right, so we'll go back to, we are machining the flatlands there, so that looks all good. Our high-speed toolpath that we got. And I think I did the zig option just so that we could see all of the linking. Yeah, I did a zig method so that we could see the linking there, and we can see it in simulation too. I'm going to blank that out because that's a lot to look at. And from that 3-axis toolpath, we are going to be indexing to the next surface here. expand the features that I've got. We're doing a facing operation and then a pocket operation. So again, we'll see the high-speed machining for the pocket here. We're just doing a standard facing for this one here, zigzag back and forth. Same workflow as we did the first facing operation, setting the number of cuts, linking and all that. And then the pocket. Pocket and a profile finish on the inside. Setting up the tool for the pocket and the feeds and speeds. Our different cut patterns. So we have a standard pocket. We also have the advanced pocket options, which gives us our high-speed machining options. So parallel, zig or zigzag. So one way is zig, not one way is zigzag in this one here. Offset pocket out from the center, pocket in from the outside. Morph spiral or adaptive roughing. And we'll look at the morph spiral in this one. We're leaving 15 thousandths of an inch on the side walls for the profile finish pass to clean up. We could leave a bottom allowance for the finish pass to clean up as well. We're just going to leave that at 0. We're going to the total depth. And we're doing 1/8 of an inch depth of cut. So that leaves us with 8 numbers of cuts there. Plunge, ramp, or spiral into the material, entering into the stock. Machine sequence, so if we're doing multiple pockets, we can set the closest sorting order. If there's a clamp or something that's getting in the way between geometry, we can sort the different parts ourselves manually. We could sort it in the X direction or in the Y direction. Or in a custom direction if we want to go at a 45-degree angle or something like that. And then also our start position and how we're going to be sorting them. We're starting in the top left corner and working our way around, or what have you. Then linking for each step over. Our advanced feed rates, we have our vert rapid moves to feed moves, linking, adaptive feed rates. Sorry, let me turn this off. So adaptive feed rates, corner slowdown option, so slowing down into the corner specifically and set the specific feed rate that we want manually. We could do that here as well. Setting up the finish tool for the profile finish operation. Setting the compensation on the left or the right side of the path, giving us our climb mill or conventional milling options. Also machine compensation if we want to, so system compensation will compensate for the radius of the tool within the G code automatically, or we could output G41 or G42 to offset for the tool at the machine. Just doing one depth of cut for the finish pass, setting a lead in and a lead out here. Corner types, so going around the sharp corners if we're doing an outside profile. Sometimes I show like the loop radius option to break up the corners, different options like that in the profile. Machine sequence and advanced feed rates. We'll compute this to take a look at the circular interpolation, and this is the morph spiral toolpath for the pocket. You can see that it does a small spiral outward so that it doesn't waste time stepping over every time for each pass. It's going to continually be removing material the whole time. Saves us time in machining that way. Then once we're done with this index, go over to the next index here. And every time I'm creating an index, I'm right-clicking on the machine setup, going to additional functions, selecting insert setup here. So this is our next one. Expand the operations I've got. It's just a facing operation. Zigzag back and forth. 3 depths of cut there. Pretty standard. Next one will be the index system. Let's see. Yeah, okay. That's just an extra index there. So last index system here will be the facing operation. Looks like I'm only doing 2 or 3 different levels there. Yeah, 3 depths of cut. So I'm doing like, yeah, so define depth at 145. So this is a depth of 145, and then this third cut is whatever is left over from that 300. So going down 145 the first time, going down 145, and then going down only 10 for that last defined depth there. Lead in, lead out, linking, advanced feed rates. Last is the drilled holes. And I have a layer of all of the holes on here. In our geometry selection, when I'm selecting them, I can go here to the Home tab, and when I'm picking each circle, it could be, it could be difficult if I want to select specific ones, or if I don't have this on its own layer. I do have this rectangle here, so I don't want to select that. We can pick and match by the certain layer it's on, pick and match by the color of the geometry I'm selecting, pick and match by line style. So if there were only dashed lines I want to select, I could select everything at once that way, or pick and match by radius. So when I have that turned on, I click on one radius. Everything that has the same radius as that one will be selected at the same time. Yeah, it's gonna give me something about the depth now that I haven't set that. So our first page here with the holes, top of feature, feature depth, center drill and drill. We can also do a chamfer drill or a chamfer mill around larger holes. Reaming and boring operations. We're just doing a center drill and a drill. Again, the sorting order, like we did with the pocket, the most optimized way. I can pick the order manually, set it in an X, a Y direction, a custom direction that I want. Set our work offset number, center drill, parameters of the drill, and plunge feed rate. If I want a depth, peck, or fast peck into the material. Setting my drill parameters and the total depth, and if I want to peck or not. We'll just finish that out. We can take a look at our simulation. Let's see, while we're getting into simulation here, looks like we got one question. So Eric asks how to maintain radial chip thickness with HEM morph spiral. That's a good question. I thought that the morph spiral, so with morph spiral, the radial chip thickness, do we not have that setting in there? Right before I get through the simulation here, let's just double check. So that's under this one. So we have the morph spiral turned on, and we only have the adaptive feed rate, the volume-based feed rate for the morph spiral. Yeah, so that's a good question. I have seen that setting before where it only gives us one and not the radial chip thinning. It looks like it's not currently a setting for the morph spiral. You would have to use adaptive roughing if you wanted to use it that way. With morph spiral, we don't have the radial chip thinning. It would be in I would think it would be in a newer build. I can create a feature request though to see how far along we are with that setting there. Or maybe if there's some reason why it's not in there. So right now the stock in our simulation is sitting inside of the chuck. I want to create a work offset so I can move it over. That's done in the machine setup here. So I right click and edit. I accidentally put it 10 inches inside of the work holding piece even more. So I'm going to move this a negative 10 inches instead of positive. Now this work offset is only for simulation. It's not going to change anything within the G-code. It's just so that you can offset the machine setup and move the stock over inside of our simulation here. So yeah, very key to HEM effectiveness. Yeah, Eric, I'll ask more about that for you after the webinar and see what we come up with. I am kind of curious too of why we don't have radial chip thinning in the morph spiral. But yeah, I'll find out for you here after this. So here we've got the facing operations first. We can see the move list here. This is our adaptive facing operation. So our first high-speed machining operation we're looking at. And then the other facing operations. If I wanted to change the machining order, I can just right-click on the milling job and go to machining order. I can select an operation, move it down or up in the list here. I can sort the machining order by the individual feature. So I click this button, it will set up all of the milling operations as it's defined in the CAM tree. By individual tool per machine setup, so individual tool, so if I've got a roughing tool first, it'll sort all of those first and then sort the next tool, the operations with the next tool next, and so on. Individual tool per machine setup. So if I've got machine setup 1, it'll sort by individual tool. If I've got a machine setup 2, then it'll sort all the operations according to that. So here we're almost done with our facing operations around the stock. And then this is, after the facing operations, the 3-axis roughing operation. This is our adaptive roughing. So this is our second high-speed machining operation here. You can see that it has a tricoidal milling here going all the way across. This is a one direction option that I've set. It's not going to be doing a zigzag, it's just cutting in the one direction there and linking each time. All right, so I will speed this up a little bit now. We can see this progress bar. These are the first 4 facing operations. From this tick mark all the way to this tick mark is the 3-axis roughing here. So that shows you how many lines of code it'll take, how much of a longer process this 3-axis milling is than any of the other milling operations. In this part file, at least. Speed it up a little bit more. So right now we're in our NC mode in our simulation. It says up at the top here that it'll take about 110,000 lines of G code. If I drop this down, we have a length mode. It'll tell us the distance traveled of the tool within the milling operations, about 5,100 inches. And then time mode gives us an estimated cycle time. We're onto the drilling now with the center drill first, and then the drill. But yeah, here with our time mode, it says it will take about 5 hours and 33 minutes based on the feed rates that I have currently. I'm really not sure what any of the feed rates are at the moment. We'd have to go in and make it probably make it a little faster for us to, but it will update the cycle times if I change the feed rates there. So here's our center drill, and then lastly the drill operation. Interesting, the progress bar has changed on us the different how long each one will take. So this is how long each one will take according to the time versus according to the lines of G code. So it seems like the 3-axis milling doesn't take as long in terms of time. The drilling takes a longer amount of time. It's just that the 3-axis milling will be a lot more lines of G code in relation to everything else, which makes sense. Okay, I think we got another question here. So Stephen asks, when doing an adaptive facing up with a 45-degree lead angle mill, how do you avoid having islands left over? So with this one, it's facing, let's see. So, yeah, I don't know if you're asking Stephen about the like the tool radius. If we have a tool radius, we used to have an issue where it would go around and wouldn't finish up that island in the center. And then maybe if you're talking about a 45-degree angle, kind of a chamfer there at the end of the tool. It used to have that, but in the newer version of 34, I believe that has been resolved. I would have to double check and see that. I'll do that now, just to test it out real quick. See which one do I have the adaptive with. This one, and I'll just do a corner radius here, 1/4 inch or 1/2 inch. Test that out. Let's turn everything else off except for that one, so we don't not trying to waste any time there. Then after this, we'll get into the 5-axis indexing and then the 4 and 5-axis deburring. Yeah, so we used to have an issue where it used to leave an island in the center there. I don't know if that's what you are referring to there, Stephen. But with version 34, our newest build, it has resolved that issue of having any kind of issue there in the center. Now everything is going, it kind of like overlaps there so that it doesn't leave anything there in the center there. Let me know if there's any issues that you have with the part file, or send it over to us and we can take a look at that. If it's like with a chamfer tool or something like that, it may be different than the corner radius I'm thinking of here. So from here, we'll go to multi-axis drilling. And so this is a 5-axis indexing option. You can see that we have our different indexes on this surface for drilling, on this surface, this, and this one. And going back and forth around the part there. Then we have a second machine setup, which is the same as the first, but we're doing a multi-axis drilling option so that we don't have to index every time. So here's the workflow that we did, similar to the first part file we looked at. We go from the machine setup, additional functions, add index, and then picked this surface to do our drilling operations right here. So we picked the geometry as these 5, did a center drill and a drill. Okay. What we were showing here, I believe, let's see what geometry we've got. Okay, so the geometry that we had selected in the first one here were the edges of the holes, top surface edges. We could also select the bottom surface edges. And then the other geometry selection that we had here was the sleeves of the holes themselves. So that can be very helpful in geometry selection for drilling, so that it will pick up the top of feature and pick up the total depth as well. And right here we're using the standard drill. In the next ones we're going to be looking at these options here. So we just leave that as standard drill for each of these index systems. So we index to this next one. We index to it by just clicking on a flat surface here. If you don't have a flat surface, I mean, if it's a curved surface, you just have to click at the point of the bottom of the surface or anywhere else and create a planar surface in this direction here to index that way. And then milling the hole, doing the feature depth. We've got the same available operations as before for drilling. And then next will be this one here, indexing to the surface, selecting the 5 holes, then indexing to this surface and drilling this hole. So that was our settings for indexing. If we want to save some time, instead of indexing for drilling holes on different surfaces here, we just created a new machine setup to separate the 2 options here. And I created a new machine setup by going to additional functions and insert setup. So this one here, in the same location as the previous one, we're just separating the indexing with the multi-axis drilling here. Let's see, so geometry selection. Yeah, which ones did we do here? We did that and we did that. Okay. So with geometry selection, we selected the 5 sleeves of the holes here. I believe we have to select the sleeves for the multi-axis. Maybe not. Yeah, so we have either surface edges that we can select or the sleeves of the holes. And then we drop this down and select multi-axis drilling for anything in 5-axis. If it was for a rotary, we also have the cross drill option, and then select our rotation axis around the rotary axis that we're doing. So this is cross drill for 4-axis, multi-axis drill for any 5-axis indexing here. Makes things a lot easier so that you just have that drop-down option in the geometry selection of multi-axis drill, so you don't have to index on each one and you need a flat surface every time. You can just go into multi-axis drill here. Same kinds of settings here. What's that toolpath? Oh, right, okay. Yeah, okay. So also with the geometry, you can select, glad I highlighted the toolpath there. So you can select things on a different plane. It will also create that retract, rotate around. This is a table rotation, so it's a trunnion that will rotate around and link to the next 5 drilled holes here as well. So that is another benefit of using the multi-axis drill. Instead of having to do 2 separate indexes on this one and then on this one, you just select all of the holes, select multi-axis drill, and it selects the linking for you. Yeah, and everything like that. Next will be the other 2 here, or sorry, other 3 of the indexes. Again, geometry selection, you're just selecting the holes. that are going around here, and it gives you that linking that you need for that. So in this simulation, we had a machine with a rotary table on it on the previous one. This one will be a 5-axis rotation where we have a platter that will rotate around the z-axis. Look at this here. We've got the axis control here. We can see that. Oops, sorry, that's the z. We want c rotation. Then we can see we can rotate the platter around, see the rotation of that, and then we can rotate the a-axis around, which would be the trunnion. And so if we reset it and then play through, you can see all of the drilled holes here and how it'll link around. Each one of them. So we've got the 5 holes, center drill, and then the drill inside of these 3 larger holes. We have some other different types of machines other than the table. We have the head table where the either have a platter or a trunnion, and then the head is able to rotate in one direction, or head where the tool will able to rotate in the around the x-axis and around the y-axis, which would be a-axis rotation and b-axis rotation. So different types of machines in here to give us a good simulation of what it would look like with the different types of machines that we have. If there isn't a specific machine that that looks like yours in the simulation, essentially all of these things here are STL files. So if you want to configure everything, we can help you with that, show you where all of that geometry selection is located. You go to CAM defaults, you go to current settings, you select your machine. So I'll select that head machine here, and then go to the next page down, machine definition. This is where you can, so you have a-axis STL. That's the STL file that I loaded in for that. You have a spindle, an STL file for a spindle. And so when you go in, you can click on this 3 dots icon to select a different STL file than what you have for your geometry of each one. And essentially you have it orientated here in the CAD workspace according to where it will be in your simulation. So that's very basically how you can create your own machine in simulation. Yeah, so let me make simulation a little bit larger for you guys. You're saying it might be a little bit smaller for you on your screen. Let me close out of layers. Let me close out of this one. I can also minimize the ribbon here to make it a little larger. I can also slide this window over to make it larger as well. Yeah, so this is the simulation for the head. Then we'll also take a look at the table, which was the trunnion previously, if you guys weren't able to see it, if it was too small. And then we'll get into the deburring simulations. So again, this is head, where you can pull this out a little bit, and then you can see the rotation of how it looks. I pause it. So I will move this out in the Z direction, move it up, so that we can see a little bit more of the machine. and the rotations of each one, you have the A-axis, that's your A-axis rotation, and the C-axis rotation. It goes pretty fast. Let me try to move it. There we go. So that's the C-axis rotation, and then the A-axis rotation. And within your machine parameters here, I'll just go back to that real quick. Go to the CAM tree. We right-click on CAM defaults, current settings. Within this file, and I forgot to mention this, so we'll go to BobCAD head machine, go to machine definition, and you can select your different part files as an assembly for your simulation purposes. You can also go to each rotation axis, like that A axis. You could see I wasn't able to rotate it a full 360 degrees and keep rotating it around and around like the C axis rotation of the head there. That's because I can go here to A axis limits. Its limits are plus or minus 120 degrees. So if there's specific limits you want to set it that you need to set it to for your specific machine, you can set them. If it's only plus or minus 90, for example, you can set that here. And then I'll change the machine from head to table, and we'll see that simulation without all the other stuff around here, so we can see it a little better. Okay. I think I can even minimize this toolbar. There we go. So if I move this around again, we've got this axis control. This is the purple tab down here at the bottom to open for being able to rotate around in the A axis. So this goes plus or minus 180 degrees. There's limits to that one. And then you've got your C axis here. Seems like there's not much of a limit to that. It gets to 10,000, I believe, or 100,000. So you're able to rotate the platter around in the C axis, rotate the trunnion around in the A axis, and then we can restart the simulation and then play it out to see the rotation of the platter and the trunnion here. Yeah, so it looks like that the trunnion doesn't necessarily rotate at all till the very end. Just the platter rotating around and the trunnion locked at a certain angle. So it's modified. Let's see, let's pause for a second here. All right, so let's go to the deburring. Let me open the chat, see if you guys have any other questions. That's pretty good. Okay. Yeah, so there's a head rotation. There's a head table. So the A-axis rotation, and then you have a platter for that one, and then the table that we just saw with the platter rotating around the C-axis, and then the trunnion rotating around the A-axis. Let's see. Okay. So yeah, nothing in chats. Okay, I think we're good. Go to the different deburring files that I've got. I've got this 5-axis one. Let's start with the 4-axis that I just had open. 3-axis wrapping group, folder deburr. So this is one that I normally show for any deburring demos. All right, and we start by going to CAM, starting a new job. This one will be with the BobCAD 4-axis milling machine. Start the stock wizard. Find our workpiece. Just going to define the stock in these files as the finished solid model. Just because we're doing a deburring on the corners there, it's not much other machining than that. So the next step is our machine setup, and we've got the x-axis through the as our rotation axis through the part, center line of the part. I'll move it. I think I need to move it another. We'll start with 10 inches. We'll see how that works with the rotary table that we're using. So next, we right-click on Machine Setup, and we go to Mill Multi-Axis. That's where the deburring features are. Next page, we set our work offset number. So number 1, G54, 2, G55, 56, and so on. We have the tool that we're using. We can use a ball end mill, or we can use a tapered or a lollipop tool, anything with a radius on it. I think normally I use an 1/8 inch ball end mill. We start with the part surfaces that we're focusing on. So we can do just all of the, with this auto detect option, it will detect all of the surface edges and do a deburring operation on all of those surface edges. Then we can take a look at user defined, where I can select any edges I want to do, or I can exclude any edges that I don't want to do in this file. Constant width of 20,000 7-inch. I can change that here. Number of cuts across it, so I can do multiple steps down along any surface edges. Any overlap of the tool path as I'm going around, it'll go a little bit further past where I started. Tool axis control. This is in 5-axis. It's in 3+2. So if we wanted to index to a certain index and then do the deburring from that index, we could do that here. 3 or 4-axis here. And then I set the rotary axis in the X direction. That was under axis. And it's the center line of the X-axis. And that's about it. Linking for each step over. I mean, you've got a rapid distance, so a rapid plane, a feed plane, different options like that, and then a lead in and a lead out as well. Setting here under the link tab. We'll hit compute. All right. So with selecting all of the surface edges or all of the surfaces of the part file, we can backplot this and see that it's going to focus on the slot here, focus around the edge, the end of the cylinder, focus on the hole in the center, and then the other edge around the other end of the part file. Go back in. Instead of auto detect, we'll do user defined, and I will select the certain edges that I want to focus on. I just want to focus on this slot and this hole, for example. And then tool axis control is 4-axis. Compute that. or if I wanted to have the whole part file and exclude a couple edges, I could do that. Under the parameters, I could do user defined and auto detect and then exclude edges as well. But we're doing user defined, and we could also select a lollipop tool and do undercutting as well on the bottom of the slot and the bottom of the hole also. I don't know if a 1/2 inch lollipop tool will be able to fit down inside of it, but we can check by selecting those edges as well. So user defined edges, I'll select the bottom ones also. And compute that. Let's see. I don't know if that. Yeah, I don't think it'll be able to fit. That's a pretty big lollipop tool to be able to fit in there. I'll make it smaller. Let's do the 1/8 inch that I had before. I know that one worked. So it will only focus on the certain areas that it's able to fit into, and we'll take a look at the simulation here. Even in simulation, it'll take off about 20 thousandths of an inch that I've set, so we'll be able to see that amount there. Let's see, the part, okay, so it's a -3.5, and my work offset, let's do -3.5. Let's do -6 inches, just to have the stock outside of the chuck a little bit further out there. There we go. So this helps us with any collisions with the geometry of the stock, geometry of the machine here, very close to each other. So I mean, we might get some red here showing that there's collisions, but we can change the geometry of that machine like before to have it look better. Let me close out all of this to make things see simulation a little bit better. So yeah, I just have this stock outside of the jaws here, outside of this the chuck, because of the certain machine that we've got here. I would go in, if this were my machine, I would go in and change the geometry of this to specifically what it is, so we can have it exactly how it would look on the machine there. Here's the first cut, and it goes around, goes on the top surface and then the bottom there. You can see exactly how much material is remaining. That's 20 thousandths, so that's a really deep cut for deburring. But again, you can go in and change that depth under the parameters if you want to. Just go back to the feature, change the constant width, and you can change the number of cuts as well in there. That's about it with the 4-axis deburring. It's pretty straightforward. You can either automatically select the part file, have everything deburred for you, and then exclude any edges that you don't want, or you can go in and select user defined and select the certain edges that you want specifically machine there. Much quicker than programming it yourself, much quicker, and yeah, much quicker and effective than using a hand tool for deburring as well. So that can be pretty helpful for you guys. 4-axis deburring and then 5-axis deburring here. So we've got some surface edges that we wanted to focus on here. Just focus on one of these kind of scallop type of areas on the part. Focus on this rib here, connecting all of this here, and then one of these edges on the solid here as well. Yeah, so it's the same kind of process, going into multi-axis, selecting deburring, selecting your work offset number, selecting your tool, selecting the part file for your part surfaces, and then these are our user-defined edges that we're focusing on, just this scallop type of geometry and this kind of rib type of thing here, and then this surface edge as well on the bottom of the part. Again, the constant width and number of cuts, maybe we'll change it to 3. And we can have it as flat as a chamfer or rounded as more of a fillet. Let's take a look at that. And those are really the only settings that we've changed there. Tool axis control, this is 3+2. So it's not simultaneously moving around, moving the tool and the table around simultaneously to fit in here and fit all along here. It's going to index to a certain location to get to this scallops area, then it will index automatically for this area and then index automatically for that area according to what it needs there. And so from here we'll simulate again. Other questions so far? So again, this one's with a platter and a trunnion. Kind of like just being able to see how things will rotate for us with the trunnion and then with the platter there. So we'll just restart and play through. So it'll do the one pass first, and then it'll do the second after. Interesting. So here's the second pass, since that one was pretty quick. Or maybe not. Maybe that was all of it. Oh, right. I did not compute the toolpath, I don't think. Let me recompute it. So here's with one pass, the toolpath. And then here's with 3 passes on each of them here. Look at the simulation again. looks like it started on that angled boss there, and then coming up the from the bottom, and then focused on the top area there. It looks like it is more of like a simultaneous where the rotary, the platter is rotating around while it's focused there. You can see the Z-axis rotation while the tool's moving around there. You can see the very slightest rotation of the trunnion so that the tool contact is right there at the edge of the ball radius of the tool instead of right on the side of the tool there. Once everything's done, you can look at it a little bit. I have to let it update for a second. Let's see. We can turn off the toolpath, zoom in a little bit, and then we can go here to this tab for view. Verification. The verification tab, and then apply or refine to see that radius a little bit better. So that's how it would look with the 3 passes. A little bit better than before. Once I apply or refine, that's all it shows us of the stock, and then I have to hit reset refine. Brings back the part file. Then I can go in, go to the next one, apply refine. Oh, maybe a little bit too much there. Zoomed in a little too much. Yeah, let that reload the part file in, and then let's see, loading. But yeah, I mean, that's about it. I'll go back into the simulation to look at the part file here for 5-axis deburring. But that's essentially what it is, 4 and 5-axis deburring. Just selecting the surface edges and selecting the part file for your surfaces, and then selecting the edges that you want to deburr specifically, or deburr all of them and exclude certain ones from there. The other option in there is if you want to do it in 3, 4, or 5-axis, and then also the depth you're going down to, and the depth you're going down to, and how many passes. Those are pretty much the settings in deburring. And then you had the there we go. And then you had the 4 and 5-axis indexing to be able to rotate the machine to get to a certain index, either on a rotary table or on a trunnion, or the head's able to rotate around to index to a certain location and do your 2 or 3-axis milling from there. And then again, the deburring here, just really selecting deburring and then selecting your edges you're deburring, the total constant width, number of passes, and if there's multiple passes, if you want to do a chamfer or rounded. Seems like if there was more of a choppy angle that we had previously with 3, we may want to go with more like 5 or 10 number of cuts to get a better radius on the corner there for deburring. And yeah, so that's about it that we're going over today, was the deburring and the indexing. If you guys had any questions with anything we went over today, please let me know in the questions box there. I can answer any questions you guys have. Anything else that you may be stuck on in BobCAD, please let me know in there. And then anything else that you may have have trouble with in the future, you can call us or email us at support@bobcad.com. We'll be able to answer any questions you guys have. Let's see. Let me try to open up the questions tab here. There we go. So Richard Schultz, why do you have an APT tab and RoboDK tab? So RoboDK is a newer partner of ours for robot arms. It is something coming out in the near future for everyone. For robot arms, you can load G-code in and be able to post a file and also load in a file from RoboDK, from that manufacturer specifically. So we're starting with RoboDK with robot arms, and then also able to program for those for other manufacturers in the near future. APT is APT is another type of newer manufacturer that we're also export an STL file or import an APT file. I believe this is more for 3D printing manufacturer to be able to support those machines as well in the near future. So you guys are able to see a little bit of the future stuff we're getting involved in here with 3D printers. I mean, you're able to save STL files as 3D printers, but we're on with new partners here, and also for robot arms in the near future too. So that's pretty exciting. Let's see, any other questions? Thank you, Eric Harmony, for the comments there. I appreciate it. I hope you guys learned some stuff with deburring and with indexing. Again, this is only my third or fourth webinar, so still getting used to the feel of it. You know, usually a demo is only about a half hour, 45 minutes. It's a little long-winded doing it for 2 hours and trying to do more of a technical type of spiel here than trying to sell people on the new features. So little change of pace, but it's nice, and I appreciate you guys are enjoying it. Yeah, hard to do online. Thanks again, Eric. It is hard to do online, you know, especially talking to people without any feedback other than this question box. So I do appreciate the nice comments there, Eric. Wish list would be to incorporate speeds and feeds like GWizard. Yeah, so the only thing we've got currently, I agree, like with GWizard being able to do like a conservative or a more aggressive approach to each one, and according to each tool, according to each material type. What we currently do have, again, is expanding the stock, and then you've got that material library. So right where it says carbon steel, you would right click and go to edit. It does give you a material library where we've got some conservative feeds and speeds in here for carbon steel, aluminum, tool steel, plastic types. I added wood. I know that's more of like a hobbyist thing for people with wood carving. You can add in your own material types in here. So you can add a group. I added wood. Go in here and add a material, and you can set up your own feeds and speeds, something that you find on GWizard or Machinist Cookbook or something like that, to be able to find the feeds and speeds you need, and then set it up in here. But I agree, the something more like GWizard, where you have more of like a slider, or you know, if you want to go more of an aggressive approach or a conservative approach, you can have those settings in there. It's a good feature request. I can ask about that. Yeah, and machining methodology as well. Yeah, different methods of each one. Yeah, tool deflection, choice. Yeah, choice of tool. Yeah, I'll go over really quickly. We do have what we have started with. I think with that was our hole recognition option. So if we right click on the milling job down here about halfway down, 3/4 of the way down, we have hole recognition. So if I select a solid model, it'll pick up all of the different hole types that I have, at least in the top plane. And then I can go to a different machine setup or different index for the other holes. But it picks up all of the diameters of different holes, if we want to do a chamfer, blind hole, the depth we're going down to. And we also have a knowledge base, if I can find that too. So that's the hole recognition, and then we have a knowledge base for it as well that I'm blanking on. But it's a knowledge base depending on the specific, like if we're going down a certain depth, if we're going to a more shallow location, we can do just a drill operation. If when it calculates the depth any further than that location, it will do a pecking. So a lot of default settings that we can set up for the hole recognition page. So we've got a lot of things to default with that. So I'd say that's where we're starting with the type of recognition type of settings that we've got there. We started with holes, and in the near future, I would say that we're going along with the certain machining recognition, feature-based recognition that other people are used to, where you can select a certain area of the part and it will give you a certain tool choice, and you can set up for tool deflection and things like that. I'm sure you know with tool deflection now, you can just kind of cheat the system by changing the diameter of the tool a little bit differently for tool deflection in there. But yeah, other than that, yeah, it looks like you guys don't have any other questions there. Again, thank you everyone for attending, and we'll see you guys next week for, if you're interested, we're going to be going over laser plasma and water jet. So anybody interested in that, same time, same day, Wednesday next week, 1 o'clock to about 3 o'clock, and we'll see you there. If not, again, thank you guys for looking at the webinar today, and hope to see you guys soon. You guys have a great day.